So, greetings. In this screencast, I am taking a look at problem 15 from exam 1. So, in problem 15, we're asked to calculate our sequence of Catalan numbers. And the problem is written as a number of parts, right? And so the idea is we're going to build up our code piece by piece until we get to our final product, in which we'll calculate a sequence of Catalan numbers, provide the user the option of plotting my sequence, and then also having a check to make sure that my input is a non-negative integer. Okay, but we're going to start by just looking at this piece by piece. And so in starting, right, in part A, we're just asked to write code to calculate the factorial of some integer n. And essentially we wrote, a fancy version of this for our exam 1 practice problem, but here we just need a simplified version. And so we're asked to write a function called n factorial, right? N factorial, because MATLAB has a built-in function called factorial. And we're just reminded that 3 factorial is equal to 3 times 2 times 1. That's how we would typically write it. Or equivalently, you could write it as 1 times 2 times 3. Or if I were to generalize this out, n factorial is going to be equal to 1 times 2 times 3, dot, 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 all the way up to n. So it's a continuous product from 1 up to n. And so I'm going to shoot over to MATLAB. I'll make sure I'm controlling my screens correctly. So I'm going to shoot over to MATLAB. And I'm going to start by creating my function. Okay. And so we're told to call our function. So it's going to be res. Then we're told n factorial. And n factorial is going to have an input of n. Okay. I'm going to start by adding my documentation. And so for that, I'll copy my function signature. All right, and then I'm just going to add a note that this is a function to compute the factorial of integer n. Okay. All right, so now factorial is essentially just a continuous product. When I'm dealing with continuous products and sums, we use what I would call an accumulator variable. When I'm dealing with a continuous product, we typically initialize our accumulator variable with the value of 1. Okay. Why? We take advantage of our multiplicative identity. The anything times 1 is that anything. So my first iteration, when I multiply some number by the current value of the accumulator, what's currently stored in the accumulator variable, it's going to be whatever that number is. Okay. When I'm dealing with a sum, well, then I initialize my accumulator with the value of 0. So I'm going to create I'll call it accum. I'm going to have this accumulator variable, and I'm going to initialize it with 1. And then my for loop, okay, I'm going to loop for I equals 1 to n. Okay, I'll do 1 to n. You could do 2 to n since my accumulator is 1, and first iteration would just be 1 times 1, which is 1. Okay, but it doesn't matter, right? It's all the same. So I'm going to use 1 to n just because it looks more like the mathematical expression which I'm trying to compute. And so as I loop for I equals 1 to n, okay, what I'm going to do is I'm going to compute, or I'm going to perform the calculation. I'm going to write accum times I, okay, and then I'm going to update the value assigned to my accumulator variable. So essentially, first iteration, right, my accumulator variable has a value of 1 assigned to it. Okay, I'm going to compute, okay, what's currently assigned to accumulator is 1, right, times 1, and then that's 1, and then that'll get stored to my accumulator variable. Next iteration, I is equal to 2. Okay, accum currently has a value of 1 assigned to it, so it's 1 times 2. So 1 times 2, then the result of that gets assigned to my accumulator variable. Next iteration, I is equal to 3. So now I have accum, which is 2, but it's 1 times 2. I'm going to multiply that by 3, and the result of that's assigned to accumulator variable, and so on and so forth up to n. Okay, and so this will compute my continuous product. And then last thing is, since I called this accum, is I need to make sure I return it. And this is just me. General habit I have is my output variable I typically always name as res. That way I can get to my last line, and I just make sure I assign to res, whatever it is I want to return. Okay. So this should work. Okay, so I'll call this n factorial. If I want to test it, okay, I can call it n factorial of say 7 is 5040. If I use MATLAB's built-in factorial function and I pass to it 7, 5040. Okay, feeling pretty good. Okay, so that's the first part. So I have a function to compute the factorial of some number n. Okay, and now in part B, we're asked to write a function called Catalan number that takes as an input n and returns a vector of Catalan numbers from 0 to n. That is, you should return a vector where the first element is C0, the second element should be C1, and the last element should be Cn. Okay, and our function should reference n factorial. Got it. Okay, so what am I going to do? Okay, so I'm going to add some spaces. Okay, so I'm going to make this a helper function. Okay, you could put them in a separate file, but it's all the same. Okay, and I'm going to save this as Catalan number. So this is Catalan number.n. Okay, and this is going to be, so function res is Catalan number. Okay, it's going to take as an input n. Okay, so I want to calculate the sequence out to term n, and then res will actually be a vector of Catalan numbers. Okay, and this case is, I could make this res, I could make it a capital RES, and we can stick with it. It's fine. So now this is going to be copy my function signature. It's going to be a function to compute the element, or to compute Catalan numbers out to term n. Okay, cool. All right, so if I look at my Catalan expression, okay, so let me see. So n is a non-negative integer, so n could be greater than or equal to 0. All right, so n can be greater than or equal to 0. So my first Catalan number, my sequence would be n equals 0. So, so yeah, all right. So my loop is going to begin at 0. Okay, got it. Got it. All right. So what I'm going to do, okay, is I'm going to start, and I'm going to create a vector to store my Catalan numbers. Okay, so now I just need to be, a little creative, right? So if, let's say n is 5, right? So I want to compute Catalan numbers out to n equals 5. What I need to remember is my sequence begins at 0. So I'll have Catalan number, n equals 0, n equals 1, 2, 3, 4, 5. So if n is equal to 5, right, I'm going to have 6 total Catalan numbers because I'm going to have to include the case of n equals 0. So I'm going to start by presizing my vector that I'm going to store my Catalan numbers to. So my vector to store my Catalan numbers, okay, is going to be equal to, and I'll do zeros. And what's its size? It's going to be 1, comma, and then how many elements am I going to have? It's going to be n plus 1. Okay, so I'm going to presize Cn. Okay, it's going to be 1 row. Then how many columns? Well, it's going to be n plus 1. It's n plus 1 because I need that case of 0. Okay, got it. And then let's loop over it. Okay, now computing. Okay, so I'm going to loop for I equals 0 colon n. Okay, so I'm going to start with this case of, n equals 0. Okay, I'm using I here as my index. Okay, and what am I going to do? Okay, well, let me throw my end in there. So let's compute this. And so I'm going to store. So now I need to be careful in terms of when I refer, right? Because I can't just use I as the index. I'm going to have to make sure I use I equals 1. Yeah, so I'm just trying to think through my sequencing. So first iteration, I is equal to 0. So when I point to an element of Cn, it's going to be the I plus 1 entry, right? Because I can't use I equals 0, right? And then that'll take me up to n plus 1. Okay, good. All right, so let's do this. Okay, now the key is that n, all right, can start with the value of 0. So I want to take a look at my factorial code. So n can take on a value of 0. Okay, well, what's the factorial of 0? The factorial of 0 is just 1, right? And so if I have the factorial of 0 is just 1, okay, so when I come to my factorial function, if I pass 0 to it, right, my accumulator value is initialized with 1. It won't actually perform my for loop, right, because it's going to go from I is 1 to 0, and there's no such vector that can go from 1 to 0 in increments of 1. Okay, so it should, right, I'll correctly give me my value of 1. Okay, cool. Okay, so it'll work, right, and then my other terms that I need in there are all greater than 0. Okay, so the question just becomes, how do I want to set this up? Do I want to compute each of these terms, individually and store them to some intermediate variable, or do I just want to write it so that I'm calling my factorial function 3 times? Okay, maybe I'll just call my factorial function 3 times because it's easy enough. And so, what would that look like? So what that would look like is I'm going to write to the I plus 1th element, okay, because the first iteration is 0 and I don't have an index of 0, I start at 1. Okay, so C of I plus 0 is equal to, first is 2 times n factorial, so this could be n factorial of 2 times, now it's not 2 times n, it's 2 times I, okay, because that's the current value of n I'm computing this term for, okay, divided by, okay, n plus 1 factorial, so n factorial of I plus 1, okay, cool, and then factorial, and that's going to be times the factorial of I. Okay, that's not C, that's Cn. Cool. And then I just need to make sure I return it. And so be res is equal to Cn. Okay. Now to make sure I run this correctly, or that my code's working correctly, I say that for the case of, so if I were to pass n equals 5, okay, then I look at my first 6 Catalan numbers, all right, n of 0 is 1, n of 1 is 1, 2 is 2, 3 is 5, 4 is 14, and 5 is 42. So let's see if we get this. Okay, so I want to call, and so let me store this. I'm going to create a C vector. So C is equal to Catalan number, and I'm going to pass to it 5. Okay, so I get 1, 1, 2, 5, 14, 42, 1, 1, 2, 5, 14, 42. Okay, perfect. Okay, only issue I just noticed is I said to spell it, I spelled it wrong. There should be an A in here, but I'm just going to leave it. Okay. All right, so there's my code, right? And so the key is just like we described it in class, kind of one of the purpose of functions is I started out by writing this function to compute the factorial. Okay, once it's working, I don't worry about it anymore, right? This just becomes some black box where I know if I pass to it some integer n, it's going to return back the factorial of n. Okay, so then when I get to my, code here, I need to compute the sequence of Catalan numbers, and I have this crazy formula, right? This crazy formula that involves the factorial of 3 terms. Okay, I'm not worried about computing it because I know I have this black box called n factorial, where if I just pass to it some integer, it'll return back the corresponding factorial. Okay, and so that's it, right? So it looks pretty simple, but that's it. You also could have taken this term here and broken it up, or you could just combine them all in one, right? It's just the same. Here I'm using I for my index, right? So I'm calling it like the ith Catalan number essentially. You could use n, right? You just want to make sure you're being careful then because you need to calculate n terms. So maybe make the input a capital N or something else, but that's totally a preference up to you. All right, so now I've got this function to compute Catalan numbers. So that was B. Okay, cool. Okay, now C is, it's important that n is a non-negative integer. Update your function Catalan number to add a check that this criteria is satisfied. So let's check to make sure that n is a non-negative integer. Okay, so let's take this in two parts. Okay, so first things first, I'm going to save this and I'm going to call this Catalan number. All right, so I get that right. Okay, and then let's do it. We want to make sure that n is non-negative integer. Okay, so let's start by first checking to make sure it's positive, right? That it's not negative, right? So I'm just going to do that via logical check, right? So let's say if n is less than 0, okay, then it's negative. Okay, then what do we want to do? Let's throw an error, right? So I'm going to throw an error, and my error is going to be that n is a negative number. N must be a non-negative integer. Okay, cool. Okay, so I'll throw an error message if it's negative. Otherwise, else, I'll do this. And then I end with an end. Okay, so what will happen now is if n is negative, bam, we'll get an error message that n is a negative number, and that n must be a non-negative integer. And since I'm throwing an error message will automatically kick us out of the function. None of this will be computed. Nothing will be returned. Okay, cool. So that's negative. We're also, or that it's non-negative. We also need to make sure that it is an integer. So what we did when we wrote our factorial code in class, for example, practice 1, is we said we could do it a couple different ways. All right, one is to just use the round function. Okay, and so what I mean by that is if I have the number, say 2.5, so if I were to round 2.5, all right, it's just going to round 2.5 to the nearest integer, right, 3. Okay, 2.25, right, 2. Okay, but if I do have an integer, right, rounding to the nearest integer, right, it's the same thing. Okay, and so what we did in class is we just added a check to make sure that my number was equivalent to the rounded value of that number, and if it is, then it must be a integer. Otherwise, it's not an integer. Okay, so let's do this. All right, let's add another door. Right, so I have door 1. First, I'm checking to make sure it's negative. Right, if it is, okay, well then I can maybe proceed to the next level. Let's see. Yeah, so let me do this. So if n is less than 0, then it's negative. So I can throw an error message that it's negative. Okay. Okay, I'm going to add an else if, right? So what will happen with the else if is if this is false, so it must be positive, it passes the first criteria that it's positive, it'll come here. Okay, and in here we can check to make sure that it's an integer. Okay, well, I'm going to check to see if it's not an integer, right? Because if it's not an integer, how do I want to? No, yeah. So I'm going to do this. Okay, so I'm going to check to see if it's negative, right? If this is false, that means it's positive. Then I'll come to else if. Okay, and in this else if statement, I'm going to check to make sure that it's an integer. And how we said we could do that is we can check to see if n is equivalent to the rounded value of n. Cool. Okay, and then I'm just going to throw in an else, right? And this else is all other cases. Okay, and so again, so what's going to happen here, right? It's if it's negative, it's going to throw an error. Okay, but if it's positive, then this is false. I'll come to my next statement, which is an else if. Okay, this else if will check to make sure that I have an integer, right? It's only going to get to this if it's in fact positive, right? If it's in fact not less than 0. So it's going to get to this, right? So it's not less than 0, it's not negative. It's going to check to make sure it's an integer. If it's an integer, right, that means it's a positive integer or non-negative integer. It's going to perform my calculation as it should. Okay, but if this is false, okay, then we must be an integer. Okay, and it would only get to this if it was positive. Okay, because that's false. If it's not an integer, for this to be false, right, then it's going to get here. So this must, then we must be a non-integer. Okay, so then for this case, I'll throw out an error message. Okay, because we're only going to get here if it's positive, and it's not an integer. So n is not an integer. All right, n must be a non-negative integer. Okay, cool. And I'm going to save that. And so let's try this out a couple times. So if I were to call Catalan number with 5, right, there's my result from before. It works as normal. If I give it -5, okay, it doesn't return anything, but it doesn't display my error message like I thought it was going to. Okay. So it doesn't compute anything, but it also doesn't. Oh, it's because here I'm calling Catalan number. Okay. And now I did update the name. So Catalan number. So 5, right? Same thing. -5. Okay, I get an error message. The n is a negative number. N must be a non-negative integer. Right? If I were to give it -5.5, right, it's going to get flagged that it's negative. If I give it +5.5, right, it's going to get flagged that n is not an integer. Okay, cool. So it seems to be working and catching those test cases. Sweet. Okay, and so again, logical statement. Okay, is if this is true, then it throws an error. If this is false, then it goes to the next statement. Okay, the next statement's now checking to see if it's an integer. If this is true, it's going to evaluate this. Okay, otherwise, if it's false, it's going to go here, which is all other cases, and so it would only get to here if it's positive, but it's not an integer. Okay, and so this one's going to be flagged with the n is not an integer. Okay, cool. All right. So that should take care of C. Now in D was add as an input a flag variable that allows the user to specify if a plot should be generated. The plot will be of Cn versus n. The plot should have a y-axis and x-axis label. Great. Okay. So, and it says you can use a helper function or just put it right in. Okay. All right. So I'm going to update this. Okay, and I'm going to just literally call my flag variable flag. Okay, and then I'm going to add a comment that, so it's flag. If flag is equal to 1, then we will plot the sequence. Otherwise, no plot. Okay, cool. And so what I'm going to do is, so after I calculate my sequence, okay, then I'll just add my check for flag. Okay, so I'm just going to add it right in here. So if, And I could just do flag, right? Because literally one just means true. So if I specify that my flag variable, and this is where you could use a string. You could add under double quotes plot. Okay, that would be fine. Um, I just tend to prefer integers, right? So I just might make flag a value of 1 means to plot. And so you could just do if flag, or just keep it general. I always tend to do, if flag is equivalent to 1. Okay, so if flag is equivalent to 1, right, then plot. Okay, and what am I going to plot? I'm going to plot in, so I'll plot xy, so it's going to be, so now I actually need to create a vector of my n values, right? So I'm going to plot, and so let me just simplify things. I'm going to say n is equal to 0 colon n. Okay, and I'm going to plot n is my x variable versus cn. And we weren't told anything about style or anything like that. So I'm going to do black circle and lines. Okay, cool. So my x label will be n. My y label might be something like c subscript n. My title might be Catalan numbers. Okay, cool. All right, and that's fine. All right, it's just if statement right in there that if flag is 1, then we're going to generate a plot. You could specify the figure and clear the figure if you wanted to. That's fine. And so, I could do a CLF if I want and clear my figure before I plot. Doesn't really matter. Okay. So now if I were to come down here, okay, testing the command window. So if I do Catalan number 5 and I specify 1 is my flag. Compute my Catalan numbers, and now I get a plot of Cn versus n. Beautiful. Okay. And if I were to give it a flag of 0, I was waiting for the plot. If I give it a flag of 0, well, there's no plot, right? So I'm not waiting. Okay, cool. And so there's just me. Okay, and it's this code works, right? We tested it before. So now I'm just adding this little check to generate a plot. And I think that's all that we were asked for, right? We said combine everything into one file. We did that. Then with your submission, write a script to confirm that it works, right? And we can easily do that, right? And so what I mean by that is just get in the habit of writing a script, so that when you submit this and turn it in for homework or an exam in this case, you make sure that I can just run it and I'm able to reproduce your results. So say exam 1 problem 15, and so testing my code for the case of 5, no plot. Okay, so we just said that. Boop. Now the case of 5 with a plot maybe. So I'll call it like CA, maybe CB. So the plot would be 1. Now showing the error with a negative and non-integer n values. Okay, and so that's where we tried calling with. It doesn't matter if we output a plot or not; it'd just be the same. So we tried -5. Let's call it C, because in all cases this will give an error. -5, -5.5, and let's do +5.5. Okay, just in terms of demonstrating the functionality of my code. Okay, and let me do a clear all just to clear it. So now the idea is just if I run this, I get CA, okay, CB, I get my same vector, right, plus add a plot, right, cool, and then I get my error for the other cases. All right, so I had that n is negative. Oh, hold on. And it looks like actually when it throws the error, it actually stops running my function. And so, I guess I would need to add a note. Right. Something like comment out all but the case to check. All right, because it actually looks like with the error message, it kills my script in its tracks. All right, because then that works. All right, but then if I want to try, let me just try the integer case. All right, then it makes it to that. Cool. So I think that's pretty much all. All right, and when I type this up in the exam, right, when we talked about built-in functions, right, I said, built-in functions, such as linspace, zeros, ones, things of that nature are fine. Just trying not to use factorial is all I was trying to get at in this one. Okay. So, yeah, so there's my solution. Let's take a look at it one more time. And so remember, key was first I started out by writing my factorial function. Once that was working, n factorial just became some black box. I knew I could pass to it some value n. It would return back the factorial. And this is a problem we worked on in class for exam 1 practice. We just added a couple extra if statements in class. I didn't do that here because we added the logical checks within Catalan number to make sure we conform to requirements for Catalan number. And in class, we also created a souped up version where we stored the factorial, the terms within that sequence. Or no, not the terms in the sequence. The user could provide a vector of integers, and you could return back a vector of factorials. That's what we did in class. And then once I had that black box working, well, then my Catalan calculation just became, pretty straightforward and simple because I just looped for 0 to n. Okay, and then for each value of I just called my factorial function to compute all three of my terms, which involved computing the factorial. Okay. And then we just built it up, right? Then we added our logical checks to make sure it was negative, or make sure it wasn't negative to make sure it was a non-negative integer. And then we added an if statement to generate a plot, right, with the user specifying a flag variable. So I hope that helps. I'll upload the code along with my screencast, and so hopefully you can take a look at that and be good to go for the next exam. Let me know if you have any questions.